Okay, guys, so now we're going to the calculator. Again, the test will be 1 part non-calc, 1 part calculator, and will look very similar to the one you just took for for degrees. Okay, so everything calculator-wise is exactly the same. The only thing is that you have to be in radian mode. So go right now to your calculator as you're talking to me and change it to radian mode. Okay, so if we start out the same thing, again, if I say sine of it, it's going to be ugly decimals, and that's the problem with radians. It may say here 2.963. You have to know right now, are you finding the angle or are you finding the ratio? So remember, it's sine of an angle equals the ratio. The angle is always right after the sine. The ratio is always after the equal sign. So if I look back at number 1 here, we are finding what this is equal to. We are finding the ratio. So we're going to get one answer. If we're finding the ratio, I do not use inverse sine. I'm just going to literally go to the calculator and hit sine of 2.963, and it's going to spit out the answer, which is 0.178. That is not an angle. That is a ratio. Look at how close these look. That's why you really have to understand when it comes to radians what you're doing. Are you finding an angle or are you finding the ratio? It gets kind of ugly here, and you got to make sure you know what you're doing in the calculator. Okay. Again, if it's cotangent, cosecant, something that we don't have, where we don't have the calculator button, remember that cotangent of an angle is equal to 1 over the tangent of that angle. So I'm just going to go to my calculator, 1 divided by the tangent of 4.9, and I get negative 0.89. That 8 rounds it up, so actually it's 1 point. This is what the calculator says right now, 0.1898. So this rounds that 9 up, which is going to round that. So, and it's negative. So I would just say negative 0.19, I guess is what I would say there. You wouldn't be able to go 3 decimal places. If you wanted to just truncate it and say it's that, I'm fine with that too. That's okay. Okay, so same calculator strokes. If you have the angle, again, I'm going to say it. If you have the angle, you're not finding the angle, you don't use inverse. Okay, now we're going to find the angle. So let's say it's cosine of theta equals 0.124. Again, theta is always going to be between 0 and 2 pi. That's telling you radians. Well, 2 pi, we like 2 pi because that's in terms of pi. If you look at the calculator stuff, it's not going to be in terms of pi. This is the ratio. We're finding the angle. So I'm going to draw my picture. I have to always get a reference angle, just like we did with degrees. So I'm going to say, what quadrant am I in if the cosine is positive? This is a positive ratio. So that's my positive quadrants, which for cosine is 1 and 4. So to get my reference angle, I have a cosine button. I'm finding an angle, so I go inverse cosine of 0.124, and that's going to give me my reference angle. So I get reference angle of 1.445. Look at how close the ratio and the angle are. That's why it's ugly. You're going to have decimals out of the wazoo. You have to understand what these decimals mean. So this is an angle. That's an answer. I'm going to put the R up there for radians. Keep in mind, this is 0 to pi over 2 is always our reference angle, which as a decimal, by the way, this is 1.57. So all of your reference angles are going to be between 0 and 1.57. From there, we decide what our answers are. So in this case, is the reference angle an answer? Yes, it is, because that's my first quadrant answer. So that's one answer. Then I got to get the fourth quadrant answer. Well, of course, I'm going to stow that in for x in my calculator right away. Now, normally what would we do? We would go 360 minus x, right? But now we're not in degree world anymore. We're in radian world. So I'm going to erase this 360, and what should I replace it with? Think. 2 pi. So I'm actually in my calculator. So I have my 1.45 whoops, it's not even 4.5, is it? It's 4.6. Let me come back here. 4.46. That was my fault. 4.46. Okay. And again, really in my calculator, I have 1.446, blah, 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 blah. I have it stowed in X. I'm literally going to type in my calculator. I'm literally going to type in 2 pi minus X. You have that stowed in for X. Okay. So you don't type in 6.28. We actually type in 2 pi. So our answer is 4.837 after we round that up. Okay, so these are our two answers. Now think about this, because with radians, again, if I do a quick, this is 0, this is pi, which is approximated to be 3.14. This is half of 3.14 is 1.57. This is 4.71, and this is 6.28. 6.28 is the approximation for 2 pi. So these are your ugly decimals. You should know these numbers here just as decimal approximations for your radians. Again, this is an approximation for pi over 2. This is an approximation for pi. This is an approximation for 3 pi over 2, and this is an approximation for 2 pi. But you should recognize those numbers so that when you go back and you check and you say, okay, 4.837, is that between 4.71 and 6.28? Yes, it is. Is 1.46 between 0 and 1.57? Yes, it is. Because again, you're going to have decimals coming out of your ears. Decimals all over the place, and it's going to get ugly if you don't understand what they're meaning. Okay, number 4. Let's do cosecant of theta equals negative 1.962. So cosecant is the reciprocal function of sine. I do not have a cosecant button on my calculator. So in my mind, the reciprocal of cosecant is sine. I take the reciprocal of this side. That means I have to take the reciprocal of this side. So when I go to my calculator, I'm typing in inverse sine. I'm finding an angle, and I take the reciprocal. Now notice, I am not going to plug in the negative, because how am I going to account for the negative? When I draw my quadrants. I know sine and cosecant, they're negative in the third and the fourth. So right there, that picture has accounted for that negative. I do not put the negative in the calculator. And remember, never, 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 never do you type in inverse, or no, never, ever, ever, ever do you type in 1 divided by the inverse of something. Never, 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 never. You're always going to do inverse sine, inverse cosine, inverse tangent first. Then you take the reciprocal of the ratio. Number 4, we didn't take the reciprocal. Why? Because we have a cosine button. We don't have a cosecant button, so we use the reciprocal function. Okay, so I go to the calculator. Inverse sine of 1 divided by 1.962. And so my reference angle is 0.5348, blah, 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 blah. What am I going to do with it? I'm going to store it in for X. Okay, is that reference angle an answer? No, that's my first quadrant answer. That is not going to be an answer. I have it stowed in for X right now. I need the third quadrant answer. Normally, we would go 180 plus X, but we are no longer in degree world. We are now in radian world. So what am I going to type in instead of 180? Pi. So I'm going to take that plus pi. Again, I'm not using 3.14. I'm using actually pi here. So I get as an answer 3.676. That's my third quadrant answer. Again, my fourth quadrant answer, I'm going to go 2 pi minus X. So in my calculator, I just type in 2 pi minus x. I get 5.748. Before I go on to the next problem, I'm just going to check. Do these make sense? Am I between 3.14 and 4.71? Yes. Am I between 4.71 and 6.28? Yes. So what are my answers? These are my answers, not degrees, radians. I put the little R up there for radians. So if I took 3.676 and plugged it back in here and checked it, I would get something pretty close. It wouldn't be exact because we rounded, but pretty close to that. Okay, again, if you're done, you think that's enough, you can go ahead and continue. I'm just going to do one more example here for those that need it. So, number 5. We'll do a nicer one this time. I'll do tangent of theta equals negative 2.6. Finding the angle. Finding the angle, so we have to do inverse. If tangent is negative, what quadrants are we in? We're in second and fourth. So I've just accounted for this negative. I do not need to put that negative in the calculator. So I'm going to type in inverse tangent of. Do I need to do the reciprocal of this? No, I don't, because I have a tangent button. I'm going to do inverse tangent of 2.6 on my calculator. I get 1.203 blah, 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 blah. Is that an answer? No, it is not. That's my first quadrant answer. I don't want to be in the first quadrant. I want to be in the second and the fourth. So I'm going to stow that in for x. Okay, so now to get this one, normally we go 180 minus x. I'm going to go pi minus x. So I go pi minus x. And my second quadrant answer is 1.938 radians. Normally in the fourth quadrant, I would do 360 minus x. I'm going to do 2 pi minus x. So I go 2 pi minus x. And I'm going to get 5.079. So that rounds up to 8 radians. So these are my answer. That's my fourth quadrant. That's my second quadrant. Is that between 1.57 and 3.14? Yes, it is. Is this answer between 4.71 and 6.28, just as approximation? Yes, it is. That and that are my answers. Okay, or those are my answers, I should say, to be grammatically correct. And that's the calculator. Put the degree, or put your calculator in radian mode. Good luck.